The National Electrical Code, or NEC, is a set of standards for safe electrical installations. It is updated every 3 years and adopted by most jurisdictions in the United States. It's important to understand the historical context of certain code requirements to fully appreciate their significance and evolution. Firstly, let's address the prohibition of panelboards in bathrooms. This requirement was introduced in the 1975 NEC. Prior to this, it was permissible, although perhaps not common, to install panelboards within bathrooms. The primary reason for this change was to enhance electrical safety in an environment where water is prevalent. Bathrooms are inherently damp locations, increasing the risk of electrical shock. By prohibiting panelboards in bathrooms, the code aimed to minimize the potential for contact between electrical equipment and water, thereby reducing the risk of electrical hazards. The 1975 NEC aimed to centralize electrical distribution and service equipment outside of these high-risk areas. Secondly, consider ground fault circuit interrupter, or GFCI, protection for kitchen countertop receptacles. The NEC first mandated GFCI protection for kitchen countertop receptacles in the 1971 edition. This was a groundbreaking advancement in electrical safety. GFCIs are designed to detect even small imbalances in current flow, indicating a potential ground fault. A ground fault occurs when electricity deviates from its intended path and flows through an unintended conductor, such as a person. GFCIs can detect these faults within milliseconds and quickly interrupt the circuit, preventing serious injury or death. The introduction of GFCI protection for kitchen countertop receptacles was a direct response to the increased risk of electrical shock in kitchens, where water and electrical appliances are frequently used in close proximity. Before 1971, standard circuit breakers would only trip in response to overloads or short circuits, leaving individuals vulnerable to dangerous ground faults. Finally, there is the spacing requirements for kitchen countertop receptacles, often referred to as the 2-foot rule. The 2-foot rule for spacing of kitchen countertop receptacles was first implemented in the 1975 NEC. This rule stipulates that receptacles should be installed along kitchen countertops such that no point along the countertop is more than 2 feet, or 600 millimeters, from a receptacle. The purpose of this rule is to ensure that appliances can be conveniently plugged in without the need for excessive extension cords, which can pose tripping hazards and increase the risk of electrical shock. Prior to the 1975 NEC, there was no specific requirement for the spacing of countertop receptacles, which often led to homeowners relying on extension cords to power their appliances. The 2-foot rule promoted a safer and more practical kitchen environment. It's important to know that subsequent editions of the NEC have refined and expanded upon these initial requirements. For example, GFCI protection has been extended to other areas where water is present, such as bathrooms, laundry rooms, and outdoor locations. Additionally, the specific requirements for receptacle spacing have been further clarified to address various countertop configurations. Understanding the historical context of these NEC requirements can provide valuable insights into the evolution of electrical safety standards and the ongoing efforts to protect individuals from electrical hazards. Consulting the specific edition of the NEC that is in effect for a particular jurisdiction is critical to ensure compliance with current code requirements. The NEC undergoes revisions and updates approximately every 3 years, reflecting advancements in technology, safety research, and industry best practices. Always refer to the latest edition of the NEC adopted by your local jurisdiction for the most current and applicable electrical safety standards. Panelboards are essentially distribution points for electrical circuits within a building. They receive power from the main service entrance and distribute it to individual branch circuits that feed lighting, receptacles, and appliances. Each branch circuit is protected by a circuit breaker, which is designed to trip and interrupt the circuit in the event of an overload or short circuit. This prevents overheating and potential fires. The prohibition of panelboards in bathrooms in the 1975 NEC was a significant safety measure aimed at reducing the risk of electrical shock in wet environments. A GFCI is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. It works by monitoring the current flowing into and out of a circuit. If there is any imbalance, even as little as 5 milliamps, the GFCI will trip and interrupt the circuit within a fraction of a second. This rapid response time is critical to preventing serious injury or death from electrical shock. A 1971 NEC mandate for GFCI protection of kitchen countertop receptacles was a major step forward in electrical safety. Before this requirement, people were vulnerable to ground faults when using electrical appliances near water. The 2-foot rule for kitchen countertop receptacle spacing is intended to ensure that appliances can be conveniently plugged in without the need for extension cords. Extension cords can be a safety hazard if they are overloaded or if they are run across walkways, creating a tripping hazard. By requiring receptacles to be spaced no more than 2 feet apart along countertops, the NEC aims to minimize the use of extension cords and promote a safer kitchen environment. The NEC is a comprehensive set of standards that covers a wide range of electrical installations, from residential wiring to industrial power systems. It is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is not a law itself, but it is often adopted by state and local governments as part of their building codes. Compliance with the NEC is essential to ensure the safety of electrical installations and to prevent electrical fires and injuries. Changes in the NEC are often driven by new technologies, safety concerns, and industry best practices. The code-making process is a collaborative effort that involves input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, and safety experts. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry and to protect the public from electrical hazards. The 1975 NEC prohibiting panelboards in bathrooms, the 1971 NEC mandating GFCI protection for kitchen countertop receptacles, and the 1975 NEC establishing the 2-foot rule for receptacle spacing are just a few examples of how the NEC has evolved over time to improve electrical safety. Staying up to date with the latest edition of the NEC is essential for anyone involved in electrical work. This includes electricians, contractors, engineers, and inspectors. Understanding the historical context of NEC requirements can provide valuable insights into the reasoning behind the code and the ongoing efforts to improve electrical safety. The NEC also addresses specific requirements for the types of wiring methods that can be used in different locations. For example, it may specify that certain types of cables must be used in wet locations, or that wiring must be protected from physical damage in certain areas. The NEC includes requirements for grounding and bonding of electrical systems. Grounding is intended to provide a low impedance path for fault current to return to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding is intended to ensure that all metal parts of an electrical system are electrically connected together, which helps to minimize the risk of voltage differences and electrical shock. The NEC addresses the proper sizing of conductors and overcurrent protection devices such as circuit breakers and fuses. Proper sizing is essential to prevent overheating of conductors and to protect against overloads and short circuits. The NEC includes requirements for the installation of electrical equipment, such as panelboards, receptacles, and lighting fixtures. These requirements are intended to ensure that equipment is installed safely and in accordance with manufacturer's instructions. The NEC addresses the specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements may vary depending on the specific hazards and risks associated with each type of occupancy. The NEC includes requirements for special equipment and systems such as emergency power systems, fire alarm systems, and renewable energy systems. These requirements are intended to ensure that these systems are installed and operated safely and reliably. The NEC is a complex and comprehensive document that requires careful study and understanding. It is essential for anyone involved in electrical work to have a thorough knowledge of the NEC and to comply with its requirements. Ongoing training and education are also important to stay up to date with the latest changes and revisions to the NEC. The NEC is a valuable resource for electrical safety information, and it plays a critical role in protecting people and property from electrical hazards. The NEC should be consulted for specific requirements related to electrical installations. The information provided here is for general educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer for any electrical work or installations. Remember that electrical work can be dangerous and should only be performed by qualified professionals. Improper electrical work can lead to electrical shock, fire, and other serious hazards. Always prioritize safety when working with electricity. Always disconnect power before working on any electrical circuits or equipment. Always use appropriate personal protective equipment, such as gloves and eye protection. Always follow manufacturer's instructions for installing and operating electrical equipment. Always have electrical work inspected by a qualified electrical inspector. The National Electrical Code is a crucial resource for ensuring electrical safety and preventing electrical hazards. It is essential for electricians, contractors, engineers, and homeowners to be familiar with the NEC and to comply with its requirements. By following the NEC and prioritizing safety, we can create a safer environment for ourselves and others. The NEC is continuously updated to reflect advancements in technology and best practices, making it essential to stay informed about the latest edition.